There is a quadratic function y is equal to x squared plus ax plus b graph on the coordinate plane. Solve for the area of the triangle ABC when a, b, and c are constants. A, b are x-intercepts and c is a vertex of the function. As we can see, this question is about solving for the area of a triangle. As we can see, solving for the area of the triangle. But it's different with the normal triangle. This is a triangle on the coordinate plane. So I made you 5 solutions in order to approach these questions. So let's think about each of them in order to solve for these questions. So firstly, let's think about the types of vertex. And through this type of vertex, we might think about the definition of a vertex. So in order to think about the types of our vertex in the quadratic function, luckily they are all defined by our leading coefficient in our quadratic function form, a. If you don't know what the a is, let's go back to our basic format of our quadratic function, which will going to be a standard form. So let's go back to our standard form to think about what the a is. And also we can think about it through the second one, like we can think about the influences of each variables from the functions. So our basic format of our standard form will going to be y is equal to ax squared plus bx plus c. And if you think about what this each variable does, we know that obviously every single function contains y and x. Y should always be the output of our function, and the x should always be the input of our function where we input its specific values. From now, let's think about what the a is. So the a value, we're going to be a leading coefficient. The leading coefficient in our quadratic function form. And if you think about just a coefficient, we know that coefficient is obviously going to be a numbers. So coefficient will going to be numbers, which we also call it as the constant. But we need to make the difference between constant. It is a constant beside variables. This is what the coefficient is. But we can think about leading coefficient is obviously different with the normal coefficient. And that is just because of the word leading. And if you think about what this leading means, then we can kind of relate this through our function. So our leading means it refers to the x squared. The reason is because we know that the highest degree power term, on our quadratic function will going to be the x squared because it is a quadratic function. So the highest degree power term will going to be a leading term. So leading is a short term for our leading term, which will going to be our x squared. And the coefficient of the leading term will going to be the highest power term's coefficient. In this case, we're going to be a. So a will going to be our leading coefficient. Let's think about what this a does. A is the most important thing in our quadratic functions variable. The reason is because we know that a value is a term that defines the types of our graph. So the first type of our graph we're going to be defined when our a value, our leading coefficient is greater than 0. Which means when it is a positive value, the graph of our quadratic functions opens, or we can say go upward. When the quadratic functions graph opens upward, for example, it will look something like this, that keeps going toward upward. It never intersects at a specific point. But then it will going to contain one most important point in the quadratic function, which we call it as the minimum or the maximum point on our quadratic function minimum point, or the lowest point on our quadratic function. And this will occur when our a value is positive value. Now let's think about the second case in our quadratic function. Our second case will going to be when our a value is less than 0, which means when our leading coefficient is negative value, the graph of our quadratic function will open or go downward, unlike the first one. When the quadratic function's graph opens downward, for example, it will look something like this, that keeps going toward downward. But then we're going to continue another most important point in the quadratic function system, which we call it as the maximum, or the highest point on our quadratic function. And this will all occur by our signs of our a value. Now we can think about the definition of our vertex here. The definition of our vertex will going to be the addition of the number of possibilities between the minimum point and the maximum point. And if we add those two number of possibilities, we're going to get the vertex. And the most important point I want to know in our vertex is they're all defined by our leading coefficient. By our leading coefficient, A. And this was the example for the second one. For the first one, the types of vertices and the quadratic function. So let's keep going with our the second one, which will going to be the influences between and the its variables from our quadratic function. We know that y will obviously going to be the output, x input, and the a value our leading coefficient, which defines the types of our graphs and our functions vertex. And now let's think about what the b will going to be. The b is exactly the same kind of concept with the a, except it is just a coefficient, not a leading coefficient. It is just a coefficient of x terms, which will going to be a variable. This is what the b is. Now let's think about what the c will going to be. C will going to be our y-intercept. And from here, we need to think about the definition and the advanced application of the advanced intercept, which will going to be our third solution for approaching these questions. There are two types of the intercepts. So there are two types in our intercepts, and the first types of our intercept will going to be the x-intercept. And if you think about what does the just intercept means, that means the point is rely on some specific axis, and it can be either x or y-axis. This is what the intercept will going to be. So we can apply directly through our definition of our x-intercept, which means when you convert into some specific coordinate, it will going to be our input, which we notated as the x value exists. And the reason why we usually notate it as just a x value, not a specific coordinate, is because we know that x is a variable, which means it changes depends on times. And the y value, which will going to be our output of our function, will turn into 0. This is what the x-intercept means. Now let's think about the second case, y-intercept. It is exactly the same kind of concept with the x-intercept, except the 0 part will going to be our input value, and our y value, which will going to be our output of our function, will turn into something. And we notate it as the y because it is a variable. And this will going to be the types of the intercepts. And we're done with the third one, which will going to be the advanced intercepts, or the definition. And lastly, we need to think about formula for solving the area of a triangle on the coordinate plane. Formula for solving just the area of a triangle is exactly equivalent with just a formula for solving for the area of the triangle on the Korean plane. And if you think about the formula, just a formula of the area of the triangle, it will going to be baseline times height of a triangle times 1/2. Or we divide by 2. This will going to be the area of a triangle. And solving for the area of the triangle will going to be our last answer for this question because they told us to solve for the area of a triangle ABC. So there is a picture for these questions. There's a picture for this question where there is a y in the x-axis and the quadratic function intersects with our triangle A, B, and C. And they gave us A, B, and C, where A, B, and C are constants. And the things that we solve here we're going to be the solutions for approaching array questions. Firstly, we know that this quadratic function is opens upward, and it will contain a minimum point as the vertex. And that means the A value, whatever that is, it will going to be a positive value. So from here we can know one thing, that A and B, so the A and B are the x-intercepts. And before we talk about it, let's think about the 3 cases of our quadratic functions format. So the first one, we're going to be a standard form. And every single form of our quadratic function form starts from our standard form. Our standard form, we're going to be y is equal to ax squared plus bx plus c. Now let's think about the second case. And if you think of what the standard form is optimized, it is just a simplified for calculating stuff. Second one, we're going to be a binomial form. And if you think about what the binomial format will going to be, it will going to be a y as an output is equal to x minus p times x minus z. And we know that p and z can be either positive or negative values. The last one, and before you think about it, let's think about what the binomial form is optimized. It is optimized to solve the x-intercepts. Third one, we're going to be a vertex form. And these are these 3 general format for the quadratic function to have. And the vertex form will going to be y is equal to a times x minus p squared plus q. And vertex form is optimized when it comes to solving for the vertex, as we can see from its name. So these 3 were going to be a forms of the quadratic function. And we need to think about these forms when it comes to solving this kind of geometric shape area on our coordinate plane. They gave us that the point A is -3, which means -3, 0. And our B, we don't know its x value, so we can just simply set it as b, 0. But we can obviously know that b value is greater than 0, which means when it is positive, because it is over a 0 value. So we need to set that b value is greater than 0. So this is the most important point in these questions. We need to convert this into some specific format, and it will going to be a binomial form. The reason is because we know that the binomial form is optimized when it comes to solving for the x-intercepts, and these are the x-intercepts that we have. So if we solve it, we're going to get y is equal to a times x plus 3 and x minus b. This will going to be our binomial form from our x-intercepts. Every time when we try to solve for a value, only thing that we need is a coordinate. Because let me talk about the strategy for solving for the a value. If we have a coordinate, we can simply input this back to our original function, and we're gonna get the a value isolated. But now let's think about what coordinate we have. We have 15, negative 15. But negative 15 is not our coordinate. It will going to be our y-intercept, which means the point is on our y-axis. So that means when our x value input is equal to 0, our y value exists. And our y value in this case will going to be negative 15. This is our point that the person who made this question gave us to solve for our a value. All you have to do is we need to use our input and output strategy that we talked about. In order to do it, we know that x is equal to input, which we're going to be 0 in this case because it is a y-intercept. All you have to do is input this back to our original function to solve for our variable. So let's input it. Our x value will going to be 0 and our output is negative 15. Negative 15 is equal to x. Instead of x, we input 0 plus 3 times, instead of x, we input 0. And then we have minus b. So we need to have the a value here, but we don't have to do it. Because from our original function y is equal to x squared plus ax plus b, it is exactly the same thing with y is equal to a times x plus 3 times x minus b, which is our binomial form that we solved. But it is exactly equivalent with our standard form y is equal to x squared plus ax plus b. So if you think about what our a value is, our a value is equal to 1. So we don't have to care about the a value now. Only thing that we need to carry is our b value here. So if you simplify our expressions, we're going to get negative 15 is equal to negative 3b. All you have to do in order to solve for b is divide whole terms by negative 3, which we're going to get b is equal to positive 5. So our full function will going to be y is equal to, instead of a, we just write 1, then x plus 3 times x minus 5. And we know that this is obviously going to be equal or equivalent with y is equal to a. Instead of a, we add x squared plus ax plus b, which is our original standard form. Now let's simplify our standard form into a standard form, our binomial form into a standard form, because it is the most easiest form. If you do, all you have to do is extend our expression. Y is equal to x squared minus 2x minus 15. And here we need to solve for our vertex. Let's solve for our vertex. Because vertex will going to be our point C, which will going to be our one of the point that is crucial when it comes to solving for our area of our triangle. So we can use our formula for our vertex, which will going to be negative 2a, negative b over 2a. So again, a is our leading coefficient, and our b will just going to be a coefficient of the x term. If you apply it, we're going to get, instead of a, we have our leading coefficient 1, so we're going to get 2 times 1, 2. In the numerator, negative b. Our b is just a coefficient, negative 2. But we have negative, which means we're going to get positive 2. And our x coordinate of our vertex according to our formula for finding it. So our x coordinate of a vertex will going to be 1. And the reason why we don't really have to memorize the y coordinate formula is because we know that 1 our axial is equal to input. And we know that from our coordinate, it will going to be 1 comma y. All you have to do is input our 1 to our original function and get our output of our function, which will going to be something. So let's input 1 to our original function. It will going to be y is equal to 1 minus 2 minus 15, which will going to be a negative 16. Negative 16 here will going to be our y coordinate vertex. So it will going to be, so our first point C will going to be 1 comma negative 16. Now let's think about what the A and the B will going to be. We know that point A will going to be negative 3 comma 0 according to the information. And the B, as we have found it, what is our point B? 5 comma 0. Now using this 3 point, let's relate this to our formula for solving for our triangle, the area of the triangle. First of all, let's think about our formula for triangle. Base times height times 1/2. But from here, let's think about the base. Our baseline will going to be the length between A and B. That means we need to think about the differences between the point A and B. But what is the length on our Korean plane? We know that for the length there is no negative. So there is no negative value because it is a length. It should be greater than 0. And our length, the most important point regarding the lengths in our coordinate plane is that the lengths were going to be the differences, as we have taught in a lot of videos, differences between coordinates. This is what the length of our base will going to be in every single length. So for our point A, it is negative 3 comma 0, and our point B will going to be 5 comma 0. The differences between them will going to be 2. There are 2 cases, 2 or 8. 2 is the subtraction, 8 is we're going to be our addition. But 2 can't be because when it comes to solving for your lengths, no negative, which means no subtraction. So our baseline will going to be positive 5, and we don't know it's whether it's centimeter or meter, but we just keep it as 5. Let's think about the height. Height will going to be from the C to the main bottom. So the point C, so let's erase this. Point C will going to be our points vertex, our graph's vertex, which will going to be comma negative 16. And the point right over here is on the y-intercept, which means the y coordinate is equal to 0, but the x, it's on the x-intercept, but the y coordinate is different. So the difference between them, what will that going to be? We're going to be a positive 16. So our height, we're going to be positive 16. All we have to do to solve it is times 1/2. Well, we made a mistake here. Since we added a 5 and a 3, it will going to be 8. So if we type 8 times 16 times 1/2, we're going to get positive 64. So our answer for this question will going to be 64. So let's review what we did here. We had the 5 solutions when it comes to solving this kind of questions, and there are 3 cases. And first of all, when you think about the vertex's types, it is all defined by our leading coefficient a, and we thought about what does each variable affects to our original function. And then this was our solutions. Let's think about the intercepts. We thought about the intercepts, x and the y intercept. And now we thought about the triangle area formula. And then we actually thought about it. There are three cases in our quadratic function format. There is a standard form, there is a binomial form, there is a vertex form. These are the three forms in our quadratic function. So we solve for every single point, and we could solve for the b point as the input and output value. But the most important point was that we convert this into a binomial form. And if you think about what the binomial form is, it is a form that is optimized when it comes to solving for the x-intercepts. And then we thought about the lengths. The lengths on the current plane, no negative value, because the length should always be a positive value. That means no subtraction, always should be addition between points or coordinates. So we eventually did 8 times 16 times 1 over 2, which became our 64. And in the next video, we're going to talk about the other ways to approach this question.